The purpose of the evaporator or cooling coil is to provide thermal comfort in a building by removing the humidity and heat from the building's air. The cooled and dried air is circulated around the building by a large fan and is then sucked back to the air handler along with the warm and humid byproducts from the people in the building. A percentage of fresh air is then added. This mixed air is passed through the primary filters to remove big dirt particulates. The resulting condensate in the cooling coil is drained away to the sewer. The heat from the building's air is absorbed through the coil fins by a cold liquid, typically chilled water, that is being pumped through the coil. The heat is then transported in the water back to the chiller. The chiller has a compressor that initially squeezes gas, turning it into a liquid, that then passes through an expansion valve, returning it back to gas and making it cold. The cold refrigerant gas absorbs the heat being carried in the water coming from the cooling coil. This chilled water is then returned to the coil. There is a separate water circuit that collects and removes the heat absorbed by the compressor's gas, which is then sent to either a condenser coil or cooling tower. In either case, the heat is transferred from the water into the air, and the resulting cooled water is pumped back to the chiller. The metal fins of the coil are typically made of aluminum that has a heat transfer efficiency of 200 watts per meter Kelvin, whereas the biofilm that often covers the fins may be 0.2 watts per meter Kelvin, or approximately 1,000 times less efficient. According to the California Society for Healthcare Engineering, it only requires a 1.5 millimeter fouling on the coil fins, 0.006 of an inch. When particulates pass through the primary filters and settle on the coil, we should expect the condensate that is produced when the warm air meets the cold coil to wash the particulates down into the drain pan, but the dust stays on the coil and often requires harmful chemicals to remove it. We now know that as soon as the condensate is produced, mold and biofilm start growing. Mold takes 4 to 6 hours to double, so it can easily multiply into 1 billion organisms in 12 days. As long as it's alive, it will cling to the coil fin. Its sticky surface attracts and grips the dirt, forming the biofilm. The biofilm reduces the heat transfer function of the coil, and consequently the air is not cooled sufficiently, nor is the humidity removed. To achieve the desired thermal comfort, either the occupants alter the thermostats or the maintenance department adjusts the chiller set point. In either case, this increases the electrical consumption of the chiller and pumps. In a typical office building, the AC system uses 60% of the building's energy, and of this, the chiller and pumps consume 70%. The 2006 ASHRAE published study estimated savings of 15 to 30% from clean coil.
Our advanced UV sterilization technology is so effective, it can also be used to clean mold from commercial evaporator coils, reducing maintenance and operating costs, saving thousands of dollars.
Yes, the USA Center for Disease Control and Prevention reported that each year 1,700,000 patients acquire infections after entering U.S. hospitals, and of those 99,000 die. But not in our hospital. We have HEPA filters. And anyway, infections can't be transmitted through the air.
On June 24, 2009, ASHRAE's Board of Directors issued a position document indicating that the AC system distributes viruses. This has been confirmed by medical studies, including a recent one for norovirus. Hospitals feel protected by the use of HEPA filters that block up to 99.97% of particulates. However, 1 cubic foot of air typically contains 100,000 microparticles. With air traveling at approximately 800 feet per minute through a 24-inch square duct, we have 80 million particles. So, on average, 0.003%, or 24,000 of the particles per minute, might break through the HEPA filter. If only some microorganisms break through, they can infect the patients. Most people would be horrified if they could actually see the toxic cocktail of microorganisms such as bacteria and virus, or flu, carried into the building by people. Once in the air, the microbes are distributed throughout the building via the AC ducts. Superior IAQ, with a reduction in staff sickness and absenteeism, often by as much as 25 to 50%. And an incredible reduction in hospital-acquired infections. One neonatal peer-reviewed study shows that after an investment of only $30,000, there was a drop in infections of 40%. Annual savings from antibiotics, lab tests, doctors, and nursing costs of an amazing $800,000.